Assalamualaikum and hello everyone. We are from Group A17. Will present Subtopic 1.1, which is Eigenvalues and Eigenvector.
What is an eigenvector? An eigenvector is a special non-zero vector x that only gets strength or shrunk but not rotate when multiplied by a square matrix A. What is an eigenvalue? An eigenvalue is the scalar that shows how much the eigenvector x is stretched or compressed when multiplied by matrix A.
Next, I will explain about how to find the eigenvalues of matrix. Before that, we must know what is the characteristic equation and characteristic polynomial. Determinant A minus lambda I equal to 0 is called a characteristic equation, and determinant A minus lambda I is called characteristic polynomial. So, I use one example equation, which is find the eigenvalues of matrix A equal to 4, 2, 1, 3. So, for step 1, we need to find the matrix of A minus lambda I, and only the main diagonal need to be subtracted by lambda. So, the matrix become 4 minus lambda, 2, 1, 3 minus lambda. Step 2, find the characteristic polynomial, which is determinant of 4 minus lambda, 2, 1, 3 minus lambda. And step 3, we need to find the characteristic equation. Determinant of A minus lambda I is equal to 0. After we calculate, we get lambda square minus 7 lambda plus 10 is equal to 0 as characteristic equation. Lastly, for step 4, find eigenvalues of A. We need to factorize the equation. Lambda squared minus 7 lambda plus 10 is equal to 0, and we get 5 and 2 as the eigenvalues of A.
Let's learn how to find the eigenvalues of an upper triangular matrix. An upper triangular matrix is a matrix with all 0 below the main diagonal. In this example, matrix A is an upper triangular matrix. Step 1. Identify the diagonal entries. They are 3, 5 and -2. Step 2. Since it's a triangular matrix, these diagonal entries are directly the eigenvalues. So the eigenvalues of a matrix A are 3, 5 and -2.
Next, I will explain how to find a basis for the eigenspace. From previous slide, we have already found the eigenvalues of matrix A, which are lambda equals 5 and lambda equals 2. Now, I will explain how to find the corresponding eigenvectors. In other words, we're finding the basis for each eigenspace. To find the basis, we actually need to solve the equation A minus lambda I times vector x equals the 0 vector. So, step 1, find the matrix of A minus lambda I. Note that only the main diagonal need to be subtracted by the value of lambda that we found. For lambda equal to 5, we subtract 5 from the diagonal elements of A. So the matrix will be 4 minus 5, 2, 1, 3 minus 5. This gives us the matrix -1, 2, 1, -2. Step 2, write the equation in the form A minus lambda I times vector x equals 0 vector. So the matrix equation becomes -1, 2, 1, -2 times x1, x2 equals 0, 0. Step 3, solve the system by express one variable in terms of another, which is free variable. Note that both rows represent the same equation, so we can choose either one to solve, and we can use substitution or row reduction method. From the first row, we get -x1 plus 2x2 equals 0. That gives us x1 equals 2x2. Step 4, substitute free variable into parameter. Since the free variable is x2, we let x2 equal to s, then x1 becomes 2s. So the vector x is x1, x2 equal to vector 2s, s, which is the same as s times the vector 2, 1. Therefore, the basis for the eigenspace for lambda equals 5 is the vector 2, 1. Next, we repeat the steps for other eigenvalue, which is for lambda equals to 2. For the first step, find the matrix of A minus lambda I. We get the matrix 2, 2, 1, 1. Step 2, write in form of A minus lambda I times vector x equal 0 vector. So the matrix equation becomes 2, 2, 1, 1 times x1, x2 equals 0, 0. Step 3, solve the system by express one variable in terms of another. From the second rule, we get x1 plus x2 equals 0. That gives us x1 equals negative x2. Step 4, substitute free variable into parameter. Since the free variable is x2, we let x2 equal to s. Then x1 becomes negative s. So the vector x is x1, x2 equal to vector negative ss, which is the same as s times the vector negative 1, 1. Therefore, the basis for the eigenspace for lambda equals 2 is the vector negative 1, 1.
Thank you for watching. We hope this helped you to understand eigenvalues and eigenvectors much better.